So, let me write the bending moment diagram in the 3 regions. Okay. So, I have bending moment M, I have bending moment M given by P into x for region 0 less than x less than or equal to L by 3, P L by 3 for region L by 3 less than x less than 2 L by 3, and P into L minus x in the region 2 L by 3 less than or equal to x less than or equal to L. Okay. That is the variation of the bending moment in the 3 regions. Okay. To find a deflected shape, you know that this bending moment is nothing but EI, this bending moment is EI d square delta y by dx square from the bending equation. Okay. So, to get the slope, that is Ey d delta y by dx, I integrate this equation once to get P x square by 2 plus C 1 in the region 0 less than x less than or equal to L by 3, and I get it as P L by 3 into x plus C 2. I will write it as x minus L by 3 plus C 2, where I have not made anything. The C 2 constant now will be the actual integration constant plus P L square by 9. Okay. So, I can do this, I am doing this because if I do this, the calculation becomes simpler. Okay, because I want this term to go to 0 and x equal to L by 3. Okay, that is why I am doing this, L by 3 less than x less than 2 L by 3, and this will be P into L minus x whole square by 2, and with a negative sign because x has a negative sign, plus C 3 in the region 2 L by 3 less than or equal to x less than or equal to L. Okay. Now, I want to integrate this equation once more to get EI delta y. So, that is going to be P x cube by 6 plus C 1 x plus C 4 the region 0 less than x less than L by 3, P L by 6 x minus L by 3 the whole square plus C 2 x plus C 5 the region L by 3 less than x less than 2 L by 3. Now, minus minus will become plus L minus x the whole cube by 6. Now, again I will make it minus C 3 into L minus x plus C 6. Okay. It will be C 3 x, C 3 x I am getting here 2, C 6 would be the actual integration constant will be C 6 minus C 3 L. Okay. But I want it to go to 0 and x equal to L, so I am writing it like this. Okay. So, L which will be 2 L by 3 less than x less than or equal to L. Okay. Now, what are the boundary conditions for this problem? The boundary conditions for this problem are the boundary and continuity conditions. I know that there is no vertical deflection at A and there is no vertical deflection at B, the right and left supports. So, delta y at x equal to 0 is equal to 0 and delta y at x equal to L is 0. This is the boundary condition. Okay. Now, coming to continuity conditions, I need a second derivative to exist, which means up to the first derivative there should be a continuous function at least. Okay. Since the second derivative exists, the first derivative also has to be continuous, which means d delta y by dx at x equal to L by 3 minus, that is to the left of L by 3 must be equal to d delta y by dx at x equal to L by 3 plus, that is to the right of L by 3. Okay. That is to the left means I use this equation to compute d delta y by dx, L by 3 plus means I use this equation to compute dy by dx at L by 3. Okay. Now, similarly I need d delta y by dx at x equal to 2L by 3 minus must be equal to d delta y by dx at x equal to 2L by 3 plus, that is at L by 3 minus I have to use this equation 2L by 3 minus, and 2L by 3 plus I have to use this equation to get the restriction due to this. Okay. Then I have delta y at x equal to L by 3 minus must be equal to delta y at x equal to L by 3 plus. Similarly, I have delta y at x equal to 2L by 3 minus must be equal to delta y at x equal to 2L by 3 plus. Okay. Now, let us look at what restriction these conditions place. The first condition, delta y at x equal to 0 tells me that from this equation I get C4 to be equal to 0. Okay. Similarly, delta y at x equal to L equal to 0 will imply that C6 is equal to 0 from this equation. From this equation x equal to L, these two terms goes off, so C6 becomes 0. Okay. Now, these are the constants found from the boundary conditions. The other constants I have to find from this continuity conditions. These conditions are called as continuity conditions. Okay. These conditions are called as continuity conditions. Now, let us apply the first continuity condition, d delta y at x equal to L by 3 minus would be, I have to use this equation L by 3 minus, this should be equal to at L by 3 plus, which is this equation. Okay. So, that gives me, basically this is equation 3, say this is 4, this is 5 and this is 6. 3 gives me P L square by 2 into 9 plus C1 must be equal to C2, because at L by 3 this term goes off, at x equal to L by 3 this term goes off, so that will be C2. Okay. Similarly, equation 4 gives me that at 2L by 3 minus it is P L square by 9 plus C2 must be equal to minus P L square by 2 into 9 plus C3. Okay. That will be coming from equation 4. Okay. Now, let us say what happens from equation 5. Equation 5 gives me I have to substitute x equal to L by 3 in this equation. C4 I know is 0, so I can drop that, and x equal to L by 3 in this equation, that will be at L by 3 plus. Okay. So, that will be P L cube by 6 into 27 plus C1 into L by 2L by 3. C4 is 0, must be equal to at L by 3 plus this is 0. So, that will be C2 to L by 3 plus C5. Okay.
C1 L by 3. L by 3 is substitute.
Yeah. It will be C1 substituting L by 3 in the first equation, you will get this as the result. Okay. Okay. Now, using 6 from 6 we will get it as, I have to substitute x equal to 2 L by 3 in this equation and in this equation, then I will get it as P L cube by 6 into 9 plus C 2 into 2 L by 3 plus C 5, okay, must be equal to 2 L by 3 minus, in this equation will give me P into L cube by 6 into 27 minus C 3 into L by 3 and C 6 is 0, okay, C 2 into 3 L by 3. Okay. Now, these are linear equations involving 4 constants C 1, C 2, C 3 and C 5. I have to solve the system of linear equations. Okay. If I solve the system of linear equations, I will get C 1 to be, I will write in the matrix form and then I will ask you to invert and solve it. Okay. So, it will be C 1, C 2, C 3, C 5 are 5 constants. This should be equal to the right hand side whatever we are getting it as. The first equation, the coefficient of C 1 is 1, coefficient of C 2 is minus 1. So, that is minus 1, C 3 is not there. So, this is 0, C 5 is not there. So, that is 0. Okay. So, that should be equal to minus P L square by 18. Okay. Now, equation 4 gives me that coefficient of C 1 is 0. I bring C 3 to the side of C 2. So, C 2 coefficient is 1, C 3 coefficient is minus 1, okay. C 5 is not there. So, that is 0, okay, and that should be equal to P L square by 6 minus, because I have minus P L square by 18 minus P L square by 9. This will be minus P L square by 18 into 3 into 3 by 18. So, that will be P L square by 6. Okay. Now, the fifth equation as C 1 coefficient is L by 3. I will take it to the other side of the equation. So, there will be minus P L by 3, C 2 coefficient is L by 3, there is no C 3, C 5 is 1, okay, and this will be equal to P L cube by 6 into 27. Okay. The fourth equation, which is the sixth equation that we have here, will bring C L by 3 on to the left hand side. So, I have no C 1 contribution there. Okay. So, C 2 has coefficient 2 L by 3, C 3 has coefficient L by 3 and C 5 has coefficient 1, and I have to take P L cube by 6 into 9 to the other side. So, this will be P L cube by 27 into 6 minus P L cube by 6 into 9, which is P L cube by 27 into 1 by 6 minus 1 by 2, right. Okay. So, this will be P L cube by 27 into 6 into 2. Okay. So, that will be P L cube by 81. Okay. So, this will be P L cube by 81. Okay. Yeah, minus PL cube by 81. Okay. Now, if I solve for these constants, I will get C1 to be, if I solve for these constants, I will get C1 to be PL square by 9 minus PL square by 9, C2 would be minus PL square by 18, C3 would be PL square by 9, C5 would be minus PL cube by 81. Okay. Now, let us go ahead and substitute these values of constants into the equations and see what the slope at different points is and what the reflected shape at different points is. Okay. So, we have E times IZZ into d delta y by dx given by P into L square by 2 x by L the whole square minus 2 by 9. Okay, into PL square by 3 into x by L minus 1 by 3 minus 1 by 6 PL square by 2 minus 1 minus x by L the whole square minus 2 by 9. Okay. This is for 0 less than x less than L by 3, L by 3 less than or equal to x less than or equal to 2L by 3. This is 2L by 3 less than or equal to x less than or equal to L. Okay. Now, let us find the specific values of this slope. Let us say this is d delta y by dx at x equal to 0 would be minus PL square by 9 and d delta y by dx at x equal to L. These are the slopes of the supports. This will be substituting in the final equation, substituting in this equation x equal to L, I will get that this is nothing but PL square by 9. They have to add the same magnitude, but opposite in direction, because one rotates in the clockwise direction whereas the other one rotates in the anti-clockwise direction. It will be evident when we draw the reflected shape. Okay. So, now similarly d delta y by dx at x equal to L by 3 would be minus PL square by 18. We obtain this by substituting x equal to L by 3 in this equation, and d delta y by dx at x equal to 2L L by 3 would be substituting again in this equation, substituting again x equal to 2L by 3 in this equation, it will be PL square by 3 into 1 by 3 minus 1 by 6, which will be PL square by 18. Okay, it will be PL square by 18. This again should have opposite sign, but same in magnitude because of symmetry and because the reflected shape is, slope has to be same at equidistance from the center of the beam. Okay. Now, finally d delta y by dx at x equal to L by 2 will be PL square by 3 into 1 by 2 minus 1 by 3 minus 1 by 6, which is 0. Okay, that should happen because the maximum deflection will occur at the midspan because of symmetry again. Okay. Now let us see what is E I Z Z into delta y. This is now P L cube by 6 x by L the whole cube minus 2 by 3 into x by L for 0 less than x less than L by 3 P L cube by 6 into x by L minus 1 by 3 the whole square minus 1 by 3 to x by L minus 2 by 27. Okay. This is at L by 3 less than x less than or equal to 2L by 3. Okay. And final equation would be P L cube by 6 into 1 minus x by L the whole cube minus 2 by 3 1 minus x by L for 2L by 3 less than or equal to x less than or equal to L. Now we are interested in finding delta y at 0 is from this equation you can see that it is 0, delta y at x equal to L is 0 from this equation. Okay. Then we are interested in finding delta y at L by 3 and delta y at L by 2 and delta y at 2L by 3. So, delta y at L by 2 would be P L cube by 6, substituting in this equation it will be P L cube by 6 into 1 by 2 minus 1 by 3 is 1 by 6, it will be 1 by 36 minus 1 by 6 minus 2 by 27, which will be minus 23 P L cube by 648. Okay. Similarly, delta y at L by 3 is going to be, substituting x equal to L by 3 in this equation or in this equation, you will get it as minus 5 P L cube by 27 into 6. Similarly, delta y at 2L by 3 would be, substituting x equal to L by 3 in either this equation or this equation, you will get it as again minus 5 P L cube by 27 into 6, 27 into 6. Okay. So, now let us draw the deflected shape for this beam subjected to 2 point loads P and a reaction force P here. First we are plotting the deflected shape. You can find that all the deflections are negative right from L by 2 and L by 3. Okay. So, the deflected shape that we get would be of this form. Be of this form, wherein the maximum deflection will occur at L by 2, maximum deflection will occur at L by 2 if this distance is L by 2, if this distance is L by 2, the maximum deflection occurs here, which is minus 23 by 648 P L cube by E times I Z Z. Okay. All the things I left E times IZZ should come in the denominator, okay, because E times IZZ is that, okay. So, in all these expressions I should have E times IZZ, okay. So, now that is minus PLQ by 648 EIZZ. Similarly, at L by 3 and 2 L by 3 it will be here, it is going to be minus 5 PL cube by 162 times CIZZ, okay. Same value here too, here also it is going to be the same as this, okay. Now, let us draw the slope, that is, now this is variation of theta, that is d delta y by dx, okay. We find that the slope is 0 at L by 2, because as expected the deflection is maximum there, and then it varies from the negative in the left hand side of the midsection to positive in the right hand side of the midsection, okay. So, the variation is something like a parabolic curve, okay. So, it does that, okay, wherein here it is PL square by 9, this is a straight line, this is also a straight line there, slope of this has to be the bending moment diagram. So, it has to be 0 at the supports, okay. This is PL square by 9, this is 0 here, okay. At L by 3 it is PL square by 18, PL square by 18, this is positive, this is negative, this is all negative deflected shape, okay.